Welcome back to lecture. This is our Algebra Review Lesson 5A. We're going to look at solutions to equations in this lesson over the real numbers. So let's get started. So, solving linear equations in this section. Linear equations are equations with just only a power of 1 in any exponent. Okay? So a linear equation of one variable is an equation that we're in the form of ax plus b is equal to 0, where a and b are real numbers, a is not equal to 0, and x is the variable. That's the variable that we are trying to find out once we write this in this form. Okay. So a linear equation in one variable is also called a first degree equation because the degree of the variable term must be exactly 1. That exponent of this x right here should be 1. A solution to an equation is a value of the variable that makes the equation a true statement. The set of all solutions to an equation is called the solution set of the equation. Equivalent equations have the same solution sets. To solve a linear equation in one variable, we form simpler equivalent equations. So they look a different form, but they're equivalent, and we continue that until the equation to solution is obvious. Hopefully we'll have x by itself on one side, a constant on the other side, and we can just read off what the value is. So the properties used to produce equivalent equations include the addition and multiplication properties of equality. Okay, so I'm going to get rid of myself here, and let's move on. Here's the properties of equality. Let A, B, and C be real valued expressions. The property name, addition property of equality. So if I've got one equivalent statement that A is equal to B, this is like 2 is equal to 2. Then certainly A plus C is equal to B plus C. So if C is 3, 2 plus 3 is certainly equal to 2 plus 3. Here we don't know what this is, but we know this side is equal to that side. And what we're going to do is try to get x by itself. So that's our game plan. This is how we play this. So I'm going to try to get x by itself on one side, all the constants on the other. And how I'm going to do this is whatever this sign is, I'm going to do the opposite. So if this is plus 4, I'm going to add a negative 4. And I want to do it on both sides because I got to do the equivalence. And then once I do that, the 4 plus negative 4 is 0. I'm just left with x on this side, and now I see that x is equal to 5. What I would do at that point was go back and put this back in to make sure we haven't made any mistakes. I'd do a check. 5, so I said x is 5. Let's see, 5 plus 4, 9 on this side is equal to 9 on that side, so we found the solution. We can also use this multiplication property of equality, and that's saying if A is equal to B, then this is equivalent to A times C is equal to B times C if C is not equal to 0. Okay, certainly if C is equal to 0, it's still going to work, but it's not going to give us anything. It's not going to help us any. It's just going to make 0 equal to 0. So let's say if this was 2 is equal to 2 and C is equal to 3, then 2 times 3 would certainly be 6, and that 2 times 3 would be 6, and it would still be equal. So here's an example. I have 4 times x is equal to 24. What I'm going to do is divide by 4, but we're going to look at it as a multiplication problem. So I'm going to multiply by the reciprocal of this, 1/4. And I'm going to do it on both sides here. The 4's are going to cancel. 4 divided by 4 is just 1, so 1x, or x is equal to 24 divided by 4 is our 6. So here's kind of our steps that we're going to try to follow when we're solving a linear equation in one variable. We're going to simplify both sides of the equation. So if there's any parentheses, brackets, we're going to clear those. Combine like terms. Consider clearing fractions or decimals by multiplying both sides of the equation by the least common denominator of all terms. Okay, if I've got decimals, I want to multiply it by a power of 10 that gets rid of all the decimals. Then we're going to use the addition property of equality, collect the variable terms on one side of the equation and the constant terms on the other side. And then finally, we're going to do multiplication property of equality to make the coefficient of the variable term equal to 1. And then check the potential solution in the original equation and write the solution set. So let's take a look at this one. I want to solve negative 3 times w minus 4 plus 5 is equal to 10 minus w plus 1, close parentheses. Okay. The quantity w minus 4, the quantity w plus 1. So remember, we want to clear up all of our parentheses. So we're going to distribute minus 3w plus 12, negative 3 times negative 4. We still have our plus 5, and then 10 minus 1 times w is minus w, minus 1 times plus 1 is minus 1. And now we can group on both sides. 12 and our 15 is 17. I still got my minus 3w. 10 minus 1 is 9 minus w. And now I want to get all of my w's on one side. I could do plus 3w and plus 3w, or I could just go ahead and do the plus w here. That way I'll have my w's over on my left. Either way would work. Get rid of my w's. And over here I end up with minus 2w plus 17 is equal to 9. Then I do my constants over on the other side. My 17 minus 17 gives me my minus 8. And finally I do that multiplication property and divide both sides by negative 2. And that gives me w is equal to 4. The negative 2's cancel here. And then if I go over here and check on the side, if I put a 4, every place I saw the 4 in the original one, I'm going to put a question mark over here as, is this true? Okay. And then once I get down and do all the arithmetic, I find out 5 is equal to 5, then it must be true. So the equation we looked at before has exactly one solution. If I have exactly one solution, or if I have an equation that has exactly one solution, that's called a conditional equation. It is conditionally true for some values of the variable and false for other values. So an equation that is true for all values of the variable for which the expression is an equation are defined is called an identity. So an equation that is false for all values of the variable, there is nothing true, is called a contradiction. So here's some of these things in here. And I challenge you to go through and find out which one is the conditional, the contradiction, and the identity. So let's look at the quadratic equations. Let a, b, and c represent real numbers where a is not equal to 0. A quadratic equation of the variable x and the equation of the form ax squared plus bx plus c is equal to 0. And to solve a quadratic equation, we make use of the zero product property if we can. So one of the first methods we're going to learn is to see if we can factor this thing. If I can put it a factor of something times something is equal to 0, then I know by this property, if two numbers are multiplied together and I get 0, then one of them or the other one, or actually both of these, could be 0. To solve a quadratic equation using the zero product property, set one side of the equation equal to 0 and factor the other side. So let's see how that works. So here we've got two things multiplied together, but it's not equal to 0. I can't really do anything in this case. This could be any set of numbers. This could be any set of numbers. 2 times 3, 3 times 2. All of those are going to be, the negative is the negative 12. Negative 2 times 3, or 2 times negative 3. All of those are going to give me negative 12. So there's many numbers that would work, and I can't just set these things. But what I'm going to do is distribute, get everything over on one side and set it equal to 0. So 2x, distribute this side, 4x squared minus 14x. I recognize this would be the same step no matter what, if I was a linear equation or a quadratic. Once I recognize this is a 2, it's not a linear, I need to get everything over on one side. I can't isolate an x squared and an x at the same time to solve. So I get everything over on one side, plus 12 gives me this. And to make it easy to factor, I want to try to factor out anything that's in common between all three. So 2 will go into each one of these. I'm going to factor out the 2. Factor out a 14, I leave the negative 7. Factor out the 2, I get my 6. And now what I'm going to do is look for two factors. There's only two that's going to work here, called x and 2x is the only thing that's going to give me 2x squared when I multiply these two. Here I could have several. I could have 6 and 1 and 2 and 3. And what I'm going to do is by trial and error, try to group these together. They have to be the same sign because the negative times the negative give me a positive, but they're going to give me a negative here, so they have to be both negative. And then I'm just going to try these things in different combinations by trial and error to see what I get. Here I finally get x times 2x is 2x squared, minus 3x minus 4x. That gives me the minus 7x, and then the plus 6. So that's my factors. Here I'm going to look at each factor being equal to 0. When is 2 ever equal to 0? Never. So I don't have to worry about this 2. All I have to worry about these two. Setting each factor equal to 0, x minus 2 is equal to 0, plus 2 gives me x equal to 2 from the method from last section, from the linear part, plus 3, that gives me the 2x equal to 3, and then I divide by 2 to get rid of the 2, and that gives me x is equal to 3/2. And it says both solutions check, but we put it back in there and then see if it gets us our original number, the negative 12. And there's our solution set. So I can do the zero product property, can be used to solve forms of these equations x squared is equal to k, or I can do the square root property down here. But what I'm going to do is do this first. So if I have something x squared is equal to k, I'm going to do this one first because I'm going to show you something here. X squared minus k is equal to 0. Then I see this as the difference of two squares. This may not even be a true square, but I can take the square root, and that gives me the solution. X minus square root of k, x plus the square root of k, plus and minus conjugates here, give me the difference of two squares. That's equal to 0, then either this one or this one could be equal to 0. So it gives me x is equal to square root of k, x is equal to negative square root of k. So I'm going to write this as x is equal to plus or minus the square root of k. Two solutions. Now, I'm going to do the square root property. If I have x squared is equal to k, then x is equal to plus or minus the square root of k. I can take the square root of both sides, but if I just do both sides, I have x is equal to the square root of k. I have to remember I'm expecting two solutions, so I need to remember to write that plus and minus when I do that square root. So let's apply the square root property in a couple of different situations. X squared is equal to 64. Here's my solution. I just take the square root of both sides. Remember, I have to do the plus and minus, and the square root of 64 just happens to be 8. So here's our solution set, plus 8 comma minus 8, or plus and minus 8. Here's another one that we can do, even though it's a compound statement in here. We have this squared, so I can take the square root of both sides, and that gets rid of the square root, but I'm left with w plus 3 in this case, and that's the plus or minus 8. So w negative 3 to get w by itself. W is equal to negative 3 plus or minus the square root of 8. And this could be written as 4 times 2. The 4 we can take out as a perfect square, and that's the 2 on the square root of 2. And that's our two solutions. Negative 3 plus 2 times the square root of 2. Negative 3 minus 2 times the square root of 2. So here are a couple of things that are called perfect square trinomials. If I expand x plus 5 squared, I'm going to do x squared, x plus 5 doubled is 10x, 5x times 2 is 10x, and then square the last one is the 25. That's the general way that you can square this out. Square the first one, multiply the two together, and times 2, and then square the last one. So what I'm going to do is divide this. So I'm going to take the square root of this n term, and I'm going to look and say, okay, what's the square root of this? That's 5. If I doubled it, do I get that term? Then it must be a perfect square, and I'm just going to write it in terms of the factored form. Here I do the very same thing. If I take the square root of 9, I get 3, and if I double it, I get that 6. I know that's a perfect square, so I'm going to do t minus 3 squared. Again, is this a perfect square trinomial? I take the square root of 49, I get 7. I double it, there's the 14. I just need to put the negative, and I can write this as minus p minus 7 squared. Okay. So for a perfect square trinomial with leading coefficient of 1, the constant term is the square of 1/2 of the linear term coefficient. So here's kind of a backwards way of doing this, is just take this, take half of it. If I square it, do I get this? Okay. So take half of it, square it, do I get that? Yep. Half of it, square it, do I get that? Yep. Half of it, 7 squared, 49. So that's another way of looking at that. So a general expression of the form x squared plus bx plus n is a perfect square if n is equal to 1/2 the b squared. Take it over there and square it. So the process to create a perfect square trinomial is called completing the square. And we can actually build that up to make sure that this works. Okay. So here we can solve a quadratic equation, x squared plus bx plus c is equal to 0, by completing the square and then applying the square root property. So this is an example of completing the square. So first of all, I'm going to factor out the 2 from each thing, so I don't have to worry about that. And in this case, since I've set it equal to 0, that's what I'm trying to look for. I can divide out that 2. So I'm left with x squared plus 10x minus 3 is equal to 0. So what I want to do is say, if this was, I want to get the 3 over here, or I leave it on that side and wait till later. But what I want to do is take half of this and then square it. If I take half of 10 and square it, half of 10 is 5. 5 squared is 25. I add it to both sides. And then I have my x plus 5 squared is equal to 28. And then I can do the square root property, take the square root of both sides, plus and minus, and then negative 5 from both sides, give me the final solution. So later on in the course, we're going to keep all of this on one side. I generally do it in class as keeping this 3, and then finally doing everything grouped together and then moving it over. But either way works fine. So that's the end of the first part of this lesson. Take a break, and we'll see you next time.